So you're going to go over quiz 2 from 2014 from unit 2. So let's describe what happens in a mass spec. What happens to the molecules and what's detected. So an electron beam, of course, knocks out. Right, mass spec destroys it. It's like knocking it out. Forms positively charged fragments of the molecule and a radical, and only the positive charged fragments are detected. What is the name of the peak that rises from the most likely fragment called? Draw the most likely fragment. So the name, and explain your answer. The name of the most likely fragment is called the base peak. In this case, you want to break a bond off that gets you a tertiary carbocation because that's the most stable, because it has 9 hyperconjugation interactions or buddies, right? Because when you form this plus charge here, there's 9 sigma bonds, 2 bonds away. 9 sigma bonds, 2 bonds away from the carbocation. That's why that's stable. Take a look here for number 3. Again, draw the molecular ion for the molecule below. Show the mechanism, curly arrows, and fragment product following the alpha cleavage. So an electron beam knocks out an electron from a lone pair. You get a molecular ion. At this point, you can do an alpha cleavage, where the electron here breaks between. This is the alpha carbon, and the alpha carbon is going to break the bond there, and you're going to get a a new pi bond, an oxygen, and a radical there. All right, as we remove those electrons. Finally, for the last one, label 3 important frequencies. Remember the molecule is down here below. A couple different things. There's lots of answers here. IR would have the 2 doublets for the CH from the aldehyde. You have the CC pi bond stretch from the triple bond. The sp2 CHs are there. You can see a carbonyl stretch. You could even show some of the CC double bond stretches as well. There's lots of options to use your table. Make sure you realize this is here. Make sure you write sp2 hybridized CHs and things like that. Alright, here, questions asking what happens to a molecule in an infrared experiment. What does information tell us? So, infrared radiation, IR radiation, vibrates and shakes bonds in a molecule, and it tells us what functional groups are present. That's the biggest thing it tells us. Here, which molecule do you predict to stretch at a higher wave number, a higher frequency, and why? So in this case, you look here and say the 2 differences here are the masses, right? Sulfur has a higher molecular weight than oxygen, so it would be harder to actually move sulfur because it's bigger back and forth, so it's more difficult to stretch. So CO will have a higher wave number and frequency, right? It's going to be easier to move the oxygen than to move the sulfur. In this one, choose the structure that corresponds to the IR spectrum below and explain your reasoning. So take a look here. If you looked at this, you'd say, well, I need to have an OH. I don't see an OH. Here, I need to have a nitrile. Well, I do see a nitrile possibly, or an alkyne, right? But the other 3 have nitrile, so that doesn't narrow that down. This one has no, no sp3 CHs, and there are sp3 CHs, so that would eliminate this. And then this one doesn't have a CO stretch, so it couldn't work here. So this is the only one that works with both the nitrile, the carbonyl, and both the sp3 type CHs.